So what do they give you? What do they want? That's what you always want to ask. So what did they give us for the first one? They gave us velocity. It says, what is the acceleration at time 2? How do you get from velocity to acceleration? Perfect. Okay, so I'm going to share my screen. Now I can't have my paper and the calculator up at the same time, but that's okay. You have it printed on your paper. You're going to type your velocity in. And here's the thing. It won't do t, so you have to do x. And usually I just go ahead and call it f of x because we're just more familiar with that. You can call it v of x. You can really use any letter of the alphabet you want, but I'm going to write f of x equals and then type that equation. So if you want to type along with me, please go ahead and do that. And then how do I get the derivative at 2 in my next box down? What am I going to type? Yep, f prime of 2. How many decimal points do you need? 3. So it's negative 0.109. Most of this is multiple choice. You'll be able to pick the answer. Again, here's my pep talk. Not every single question is going to be really hard. Some of them will be really hard, but some of them will be pretty easy. You have to not get intimidated by the difficult ones and then stumble on the easy ones. That's an easy one, right? Okay. And remember, what's a good grade? 50%. Okay. Because this quiz is going to get your curve. Number 2, what did they give us? Velocity. How many times, so not what are they, but how many times does the particle change direction? Again, we're going to go and type that in. So clear out what we just did. And again, I would just write f of x because it has to be x's instead of t's. And after you type it, you want to think about your window, if they gave you one. So did they give us a window? Yeah, what is it? Negative 5 to 5. So the way you do that is, see this wrench right here? You're going to click that. And where it says x-axis, do you see where I have my cursor right there? You're going to change that negative 5 to 5. And then the question was, how many times is there a change in direction? What do you think? Even just let your instinct kind of kick in. 3. Why 3? 3 is the correct answer. Yeah. Oh, and I love how you said that crosses the x-axis. Say it came down and just touched the x-axis and bounced back. Would that count? No, because it's not a change. Okay. Right. That would be like, yes, exactly. That would be like you're going forwards and you stop and then you keep going forwards. I'm not sure why you would really do that, but, or I guess like you hit a red light or something. Yeah. But anyway, 3 is our answer. That's it. What do they give you for the third one? Position. It says, what is the velocity when the acceleration is 0? We're going to need velocity and acceleration. So let's go ahead and find both of those. We're going to have to actually do some math here. The first 2 we just put in the calculator. This we're going to have to actually work out. So what is your derivative of sine? Cosine. So it's 2 cosine t plus what? 2t. Good. And then do another derivative. What's your derivative of cosine? Good. So it'll be negative 2 sine of t plus 2. Good. So we found both of those. It says when acceleration is 0. So we're going to set our acceleration equal to 0. And there's where we're going to use our calculator because it's calculator allowed. So we're going to clear out what we had before and in that first one. And again, I'm just going to type f of x. We're going to plug in negative 2 sine x plus 2. Your default setting is radians, so just don't change that. You want to be in radians. If you're not sure what you're in, hit that little wrench and just make sure radians at the bottom is what's highlighted. So you want to be in radians all the time. So it looks like a sine wave that's reflected and moved up to vertical stretch by 2, all of that. Do we need an interval? Did they give us an interval? I feel like they must have here. 0 to 2 pi. So you're going to make your beginning 0. Now, when you type 2 pi, you can type 2 pi. If you type pi, that's how you spell pi. Like that will put that in there. So 2 pi. So we want where this equals 0. Do you see how that's like right here? You guys have it so easy. It is so nice on Desmos. Look at that. What time are we talking about? Pi over 2. Do you see how we got that? All right. So it says, what is the velocity when acceleration equals 0? So that's what is the velocity at pi over 2. So we want to do velocity at pi over 2. I know you have a calculator, but I'm going to have us just work this out by hand. You can practice our unit circle. Cosine of pi over 2. Where is pi over 2 on your circle? Up. Cosine is the x part of the point, so that would be 0. Times 2 is 0. Plus 2 times pi over 2. So it just ends up being pi because these 2's cancel out. And again, it'll be multiple choice, so you'll be able to pick it. All right, last calculator one, and then we'll put the computers away. What do they give you? Position. It says, what is the velocity when the particle is at the origin? All right, first, we know we need velocity, so let's go ahead and find that. That's a real simple derivative, just power rule. Now, at rest means velocity is 0, it means you're not moving. But at the origin means your position equals 0. We want our position to be 0 at the origin. It says the origin, but like in a story problem, that would be like at home or at, or like if you're doing a hot air balloon, it would be like on the ground. You get what I'm saying? Like it almost makes more sense if there's a story, but we want to set position equal to 0. So I saw some of you start typing it already. We're going to go ahead and put in that position function. Again, use x. And we don't want that interval anymore. So if you hit this little home button, looks like a little house, it'll put 0 back in the center for you. So you can see it a little bit better if you hit that little house button. But we're going to click on where this equals 0, which is right there. So I got 0.31767. Is that what you guys got? All right, so let's write that down. We want time 0.3. Sorry, I can't have my paper up here at the same time as the computer. But anyway, that's the time that we got. It says, what is the velocity at that time? So you're going to take that number and plug it into velocity. And just use all the decimals so it'll be accurate enough. Again, it'll be multiple choice. So if you get close enough, you'll be able to pick the right answer. But we want the velocity at that time. So we're going to plug that in to our velocity. Forgot the 3 on. I got 2.396. So confirmation. All right. So I just took that time and plugged it in. So those are the only calculator ones, so you can go ahead and set that aside. It'll be the same when I give you the quiz, just the first 4 are calculators, so you'll do those. When you finish them, you'll set the computer aside, and then the rest are non-calculator. But again, most of it's multiple choice. And again, not every question is super hard. Some of them are, but we got to celebrate the easy ones. This next one I would say is not too bad. What do they give you? Position, and they ask for average velocity. What does that mean? Slope, regular old slope. So you need 2 points. And it says from 0 to 2. So we're going to plug in 0, plug in 2. And this actually turns out really nice because if you plug in 0, what do you get? You get 0. And if you plug in 2, 2 cubed is 8 times -2, -16. And then you're just going to do a slope. Sorry, I know I did that kind of quick, but that's not really even a calculus problem. That's an algebra problem. You're literally just doing slope. So what does that all boil down to? -8. Good job. This one, they give you position. They're asking, when is the particle at rest? Or how do you find at rest? Let me just throw that question out there. Yeah, velocity is 0. So we're going to get our velocity, set it equal to 0, do a little bit of algebra. So what is our velocity going to be? Good, 3t squared minus 18t plus 15 equals 0. Do you guys feel like you could finish that on your own? Like do algebra, factor it? Then I'm going to leave that and keep going because I want to have enough time to finish all it. Like, you would divide them all by 3? Do you get what I'm saying? Factor it. Okay, I'm going to leave that because you guys can do that. Using the same equation as number 6, the same equation, what do we know about the particle's motion at time 2? Oh, you know what? I am going to have to finish it because this is never mind. I am going to have to finish it because this question piggybacks off of that one. Tried to save you some work, but we still need it. All right, what is that going to factor into then? It's not that hard. Yep, -5 and -1, good. So we are at rest at 1 second and 5 seconds. If you get a negative time, then what do you do with it? Just throw it out. You just don't use it. Just don't do negative time. All right, so what do we know about the particle's motion at time 2? You want to look at velocity and acceleration. So let's do velocity at 2. And you don't need to figure out what it actually is, just whether it's positive or negative. So if you plug 2 into this, 2 minus 5, negative. 2 minus 1, positive. A negative times a positive is negative. So what does that mean if your velocity is negative? Moving left. Good job. And if it was a story, it might mean moving backwards or moving downwards, or, I almost think they're easier if there's a story attached because then you can visualize. So moving left. All right, and then we're going to get our acceleration and we're going to plug 2 in. So look back at your velocity that we did. It's right here, this 3t squared minus 18t plus 15. Do the derivative again. That would be 6t minus 18. And then we're going to plug into, again, you don't need to figure out what it is, just whether it's positive or negative. If you plug 2 into that, do you get a positive or a negative? All right, everybody just started talking in the hallway and we all stopped thinking. 6 times 2, 12 minus 18 is negative. So we're moving left, and are we speeding up or slowing down? Why is it speeding up? Same sign. Speeding up in the negative direction. Again, it's like you jumped out of an airplane and didn't pull the parachute yet. Like you're moving downwards and gravity is pulling you downwards. Lily, can you shut the door? This always happens in the lunch block because people don't stay in the cafeteria. All right, so we are given position at 4, velocity at 4, and acceleration at 4. That's what these mean. A derivative is velocity, a second derivative is acceleration. And actually, I should say we aren't given them. We're just told whether they're positive or negative. If your position is positive, that means you are to the right of 0. You're starting out in a positive position. It's kind of like you're not home. Your story starts out somewhere other than the starting position. You're to the right. If position was negative, you would be to the left of 0. We close the Chromebook. All right, and then this is your velocity. Velocity is also positive. What does that mean? If velocity is positive, you're moving right. Good. And if your acceleration is negative, so velocity is positive, but acceleration is negative, what does that tell us? Slowing down. Good. Velocity is positive, acceleration is negative. So I'm going to show you a visual. If you don't want to draw it and you can just imagine it in your head, then that's fine, but I'm going to show you what this looks like. Here's 0. We started out to the right of 0. I don't know exactly what it was, but to the right of 0. And we are moving right. So the way they word this is moving towards 0 or moving away from 0. So which one are we doing? Yeah, we're moving away from 0. and slowing down. These are the two things that it's going to say. So it's either going to say like your choices would be moving towards 0, speeding up, moving towards 0, slowing down, moving away from 0, speeding up. Do you get what I'm saying? Moving away from 0, slowing down. Like those are what the options are going to be. All right, what did they give us for this one? They gave us position. Hold on one second. All right, so they gave us position. They want to know at rest. So what does that mean? Velocity is 0. So we're going to have to get our velocity. So what's your derivative of cosine? So it's negative sine, and there's actually another rule there. It's negative sine pi over 2t. Good. You have to chain on the derivative of pi over 2t. Now, the derivative of 3t would be 3. The derivative of 7t would be 7. So the derivative of pi over 2t is pi over 2. Remember, pi is a number, so it's just a value. Oh, and I just didn't get to that yet. And then minus, and the derivative of pi over 2t is just pi over 2. Again, for the same reason. Remember, pi is a number, so pi over 2 is just a number. Now, again, at rest means we want that to equal 0. Yeah. If it's not just x, if there is more stuff inside than just x, then there's a chain rule. So, for example, if this was just cosine of t, no chain rule. Cosine of more than just t, like there's more stuff than just t, then you're going to have a chain rule. So like if it was cosine of 5t plus 7, you'd have a chain rule. Okay. What would you do to start solving this? We're going to add over the pi over 2. So I just added that to the other side. There's a lot of just rewriting what was there. Math is like that sometimes, though. That's my pep talk for that. Sometimes you just recopy what's there. All right. Then what? We're still just trying to solve. Yeah, you would divide by pi over 2. They would actually just cancel. So you'd get 1, but the negative I'm going to move to the other side as well. So it'll actually be -1. Now we have to do some unit circle. Think about your unit circle. Where is sine -1? And you can just say up, down, left, right.
Down.
Down. What is that amount of rotation for the downwards? 3 pi over 2. Good. Nice job, guys. You did it. Now the pi and the 2 are going to cancel. And so you actually just get 3. Do you see what I did there? Like these just cancel. It's literally just 3. Don't overthink that. Okay. I think I can do one more. Because these go with the graph. So we'll save that for after. All right. What do they give us? Position. They want acceleration. All right. So we're going to have to get velocity first and then acceleration. So what is our velocity equation going to be? Yep, -10t. Sorry, I started writing -5. -10t minus 3. Perfect. Beautiful. And then acceleration, -10. Now it says at time 6, but that kind of doesn't even matter. At time anything, your acceleration is just -10. That's all that it is.